Have you ever wondered why we don't fall off the Earth? Because there is gravity that attracts us towards the center of the Earth. Gravity is also what enables Captain America to exercise his biceps and pecs.
1, 2, 3, 4, 5.
So what on earth is gravity? Newton defined it as a force of attraction between any two masses. Just like the sun attracts our Earth, every particle in the universe attracts every other particle. Newton's law of gravitation states that the force of attraction is directly proportional to the product of the masses and inversely proportional to the square of the distance between the masses. This just means that objects with higher masses and that are closer together attract each other with a larger gravitational force. This explains why a guy might not be able to attract the girl he likes. Maybe it's because he is not massive enough, or they are not close enough. Newton's idea of gravity seems to be perfect, but someone begged to differ. Einstein described it as a curvature of space-time in his theory of relativity. We can understand this curvature of space-time as the bending of the path of objects. Imagine an originally straight road. A car on it will travel from one end to another. With a mass, the path is bent, and the car still travels from end to end, except that its path is curved. Depending on the mass of the object, the degree of curvature is different. The car may either be deflected, or orbiting, or crash into the mass. This leads to the consequence of a singularity, or as it's more commonly known, the center of a black hole, of which the mass is so great that it causes space-time to be so curved that an object traveling on it can only travel to the center. Remember, it doesn't just cause a curvature of space, but time as well. This can lead to a very strange effect called time dilation. Consider two twins, one on Earth and one near a black hole. After what seems like 5 years for the baby near the black hole, he will be a young boy. But for the boy on Earth, over 100 years will have passed and he will be an old man. This is because closer to the singularity, time runs slower relative to us here on Earth. Another theory of gravity is called quantum gravity. There are 4 fundamental forces in our universe, namely strong nuclear force, weak nuclear force, electromagnetic force, and gravity. Physicists have shown that the first 3 are all quantized and transmitted by particles. Quantized simply means there is a smallest value that the magnitude of the force can have, and the magnitude of the force can only exist in multiples of the quantum value. Gravity, by analogy, should have the same property. Therefore, the curvature of space-time is quantized. That is how quantum gravity came about. Physicists predict that gravity is transmitted through a particle called a graviton. However, general relativity, being a theory out of classical physics, does not seem to be consistent with quantum theory. Therefore, many different approaches were taken by physicists to try to unify quantum theory and general relativity. Currently, the most popular theory of quantum gravity is string theory and loop quantum gravity. That's probably all we know about gravity. Gravity is a fundamental part of the universe, one of the 4 fundamental forces, and was created out of the Big Bang as the universe expanded. It is so important to us, from daily activities to the formation of stars and planets. Therefore, we are keen to understand gravity fully to have a more complete picture of the universe and our existence.